Understand the physical chemistry of molecular polarity. A molecule's overall polarity is determined by both the individual bond dipoles, which are determined by the electronegativity differences between the bonded atoms, and the three-dimensional molecular geometry, which determines whether these individual dipoles cancel one another out or combine to produce a net dipole moment. Analyze the Lewis structure and geometry of Bf3. Boron, B, has 3 valence electrons, and each fluorine, F, has 7, totaling 24 valence electrons. The central boron atom forms 3 single bonds with the 3 fluorine atoms and possesses no unshared, lone, pairs of electrons. According to Vesper theory, a central atom with 3 bonding domains and 0 non-bonding domains assumes a symmetric, two-dimensional trigonal planar molecular geometry with bond angles of 120 degrees. Because the 3 highly polar BF bond dipoles are of equal magnitude and arranged in a perfectly symmetric planar geometry, they pull in opposite directions and cancel each other out completely, resulting in a nonpolar molecule with a net molecular dipole moment of 0. Analyze the Lewis structure and geometry of NF3. Nitrogen, N, has 5 valence electrons, and each fluorine, F, has 7, totaling 26 valence electrons. The central nitrogen atom forms 3 single bonds with the fluorine atoms and retains 1 unshared, lone, pair of electrons. According to Vesper theory, a central atom with 3 bonding domains and 1 non-bonding domain assumes a 3-dimensional trigonal pyramidal molecular geometry with bond angles of approximately 107 degrees. Because of this nonplanar geometry, the polar NF bond dipoles do not point in symmetric opposite directions to cancel out. Instead, their downward dipoles reinforce one another, combining with the dipole contribution of the nitrogen lone pair to create a permanent net molecular dipole moment, making NF3 a polar molecule. Identify the correct option. The lone pair of electrons on the nitrogen atom forces NF3 into a nonplanar geometry, which prevents the polar bond dipoles from canceling out. This confirms option D is the correct answer. The correct answer is option D. Unlike Bf3, NF3 has a nonplanar geometry due to an unshared pair of electrons on the N atom.